elasticity depends upon the value of Young's modulus, where stretching and deformation is maximum, and which among the given four has higher Young's modulus? It is steel. So steel has the highest elasticity. Fundamental frequency is inversely proportional to length and inversely proportional to diameter. Hello students, this is Samson Deepak, Faculty of Physics, Temple of Excellence. My dear students, in today's session, we will analyze the CET paper of the year 2010. And this paper has actually reflected the conceptual strength of physics. When many of us felt physics is simply principles and problem-based, this paper opened up the field and told, yes, there is also something called as concept, and it is completely, thoroughly based on topics. So we will start understanding, analyzing, and bisecting each question. The first one. The problem says the dimensions of resistance are same as of where H is Planck's constant and E is the charge. Problem ಏನು ಹೇಳುತ್ತಂದ್ರೆ dimensions of resistance. The dimensional formula for resistance is one among the given options, where H is Planck's constant, E is the charge. Andre, my dimensions for resistance should be in terms of charge. Now, let us pull out the basic definition of resistance. So we told resistance is voltage divided by current, R equals V divided by I. Now, I need to alter this so that I can introduce a term called as charge. Simple ಆಗಿ ಬರೆದ್ವಿ, resistance is V divided by I ಅಂತ. ಆದರೆ all my four options clearly is in terms of charge. So how do I introduce charge here? This manipulation you should know. ಇದನ್ನೇ concept based solving ಅಂತ ಕರಿತೀವಿ. Now this is potential. We know potential is W by Q. Work done to move the charge in the electric field. Charge bantu. So I am manipulating potential or voltage as W by Q, and I write R is equal to, instead of V, W by Q into I. As of now, Q is the charge. So V is W by Q into I. What is the dimensions of work? Same as the dimensions of energy. So this is M L square T minus 2. Work has the dimensions of energy, which is M L square T minus 2. Dimensions for charge. Yes, we know I is Q by T, or Q is I into T. So this is ampere into time, again ampere. Q is ampere into time. I is ampere, or this is M L square. T goes to the numerator, T minus 3, ampere minus 2. So this is the dimensions of resistance. Now I have to check which of the following options have the same dimensions. I'll give you the hint. ಒಂದು ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. ಎರಡನೇದು ಎಲ್ಲಾದ್ರೂ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ನ ಎನರ್ಜಿಲ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದಾ? ಬಿಕಾಸ್ ಹಿಯರ್ ವರ್ಕ್ ಹ್ಯಾಡ್ ದ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಎನರ್ಜಿ. ವೆರಿ ಗುಡ್. Energy of a photon, E is equal to h nu. So H is E divided by nu, which is frequency. H you get divided by any of the options you do. I'll give you the hint. Please do solve. The first option will be the answer. So, nodi, concept gottidre, link to link I can manipulate. Next one. A simple one. The question appears to be big, but a very simple question to understand. A train is moving slowly on a straight track at a constant speed of 2 meters per second. So there is a straight track and a train is moving on the straight track with a constant speed of 2 meters per second. This is the train. It is moving on a straight track with a constant speed of 2 meters per second. A passenger in that train starts walking with a steady speed of 2 meters per second to the back of the train. Very important word. A passenger moves with a speed of 2 meters per second to the back of the train, which means in the opposite direction of the motion of the train. So suppose train is moving along x-axis. What I believe, the passenger moves opposite with a speed of 2 meters per second. Now, what will be the relative velocity of the passenger with respect to train? Relative velocity of the passenger with respect to train. They are moving in opposite directions. So this is 2 minus 2 because they are moving in opposite directions. Passenger has the relative velocity opposite to the velocity of the train. For an observer standing on a platform directly in front of the passenger, not of the train, in front of this passenger. So there is an observer in front of the passenger. The velocity of the passenger appears to be relative velocity of the passenger with respect to the train is 0. Now, for this observer, the velocity of the passenger should be what? They are in 2 different frames. And in this first frame, the relative velocity is 0. And that is what will appear to the observer outside. So again here, the relative velocity is 0. Nodi, illi with respect to the passenger and the train, relative velocity of the passenger with respect to the train 0 agoitu. Yake averudunu opposite direction alli move agtide. So idondu frame allide, observer is in the different frame. Here relative velocity is 0. That is what is experienced by the observer. So the answer is 0. Third one. Again conceptual. A ball rests upon a flat piece of paper. So this is the paper on a tabletop. On a tabletop. The paper is pulled horizontally but quickly towards the right. Relative to its initial position with respect to the table, what happens to the ball? Carefully understand, Madi. There is a ball which is on the paper and the paper is on a tabletop. Completely no description about the friction. Rough surface illa. So I have to assume it is a smooth surface. So a ball is placed on the paper, which I say is placed on a smooth surface. Now, I will just apply horizontal force and pull the ball towards the right. I say, even if this happens, the ball is stationary. Why is it stationary? For the simple reason, it is in a state of rest. Inertia of rest. Sudden acceptance to change is not there. Only when I believe absence of friction. So, it remains stationary if there is no friction between the paper and the ball. ಅವ್ರೇನಾದ್ರೂ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿ ಅಲ್ಲಿ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಬಗ್ಗೆ ಹೇಳಿದ್ರೆ, based on that condition, I would have assessed the next two options. But basically, there is no friction at all. So the ball has to remain stationary due to inertia of rest. And therefore, only the first statement supports the given condition. Next one. IPL season. All of you are enjoying cricket. For my cricket fans, a beautiful question. A boy throws a cricket ball from the boundary. ಇದನ್ನ ಶಾರ್ಜಾದಲ್ಲಿ ಬೌಂಡ್ರಿ ಅನ್ಕೊಳ್ಳೋಣ. To the wicket keeper. And this is the trajectory, the path of the ball. Now understand. If the frictional force due to air cannot be ignored, frictional force cannot be ignored, the force acting on the ball at the position X are represented by, ಅವ್ರು ಏನ್ ಹೇಳ್ತಾರಂದ್ರೆ, ಬೌಂಡ್ರಿಯಿಂದ ಆ ಒಂದು ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಬಾಲ್ ಅನ್ನ ವಿಕೆಟ್ ಕೀಪರ್ ಕೈಗೆ ಎಸಿತಾ ಇದ್ದಾರೆ. He says, you cannot neglect the frictional force. Now, friction due to air has to be considered. Then it is at this point X, which are the different forces acting on the ball. Good. Evidently, the first one, the downward force, which is the weight of the ball. So, a ball idre, the first one will be the weight of the ball, which is mg. Now, what is friction doing? Opposing the motion of the ball. The ball is flying in this direction. Friction of air is there. It will oppose the motion in the opposite direction. So, this is the frictional force. So, which is the correct representation? A is the correct representation. Next one. If the linear momentum of a body is increased by 50%, linear momentum of the body is increased by 50%, then the kinetic energy of the body increases by, as I have done in all my previous sessions, what is the relationship between kinetic energy and linear momentum? Very good. Kinetic energy is proportional to P square by 2m. Kinetic energy, P is the linear momentum. In this case, the mass of the body is the same. So, K is proportional to P square. Why? under the assumption mass is the same. Now, therefore, K2 by K1 is P2 by P1 but whole square. According to this expression, K proportional to P square, K2 by K1 is P2 by P1 whole square. P2, momentum is increased by 50%. If the initial momentum is 100, now it is increased by 50%, which means this is 150. Initial momentum is 100. So, this is 9 by 4. I want the increase in kinetic energy, not simply kinetic energy, change in kinetic energy. So, K2 minus K1 minus K1 or minus 1 into 100 equals 9 by 4 minus 1 into 100. So, on simplification, 125% will be the answer. So, something from rigid body dynamics, concept based on moment of inertia. The moment of inertia of a circular disk of radius 2 centimeters and mass 1 kg about an axis passing through the center of mass but perpendicular to its plane is 2 kg meter square. Simple ಆಗಿ ಏನು ಹೇಳ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ ಇಲ್ಲೊಂದು ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕ್ ಇದೆ. The radius of the disk is 2 meters. Mass is 1 kg. And moment of inertia about an axis passing through the center, IXY. Moment of inertia about an axis XY passing through the center is 2 kg meter square. I have to find the moment of inertia about an axis parallel to this passing through the edge of the disk. Andre, I have to find the moment of inertia about x dash, y dash. There are two axes which are parallel to each other, and moment of inertia about a parallel axis. Yes, parallel axis theorem. So what did parallel axis theorem say? Moment of inertia about a parallel axis is equal to moment of inertia about I dash y dash is equal to moment of inertia about a given axis plus m r square. Please to note down, this is called the parallel axis theorem. Moment of inertia about a parallel axis equals moment of inertia about a given axis plus mr square. What is moment of inertia about a given axis? This is 2 plus mass is 1, radius is 2 square. So 4 plus 2, the answer is 6 kg meter square. Seventh one. An astronaut on a strange planet. Planet is very strange ante. Some planet anta artha. Finds that acceleration due to gravity is twice as that on the surface of the earth. On the planet where the astronaut is existing, acceleration due to gravity is twice the surface of the earth. Arthal ಎಷ್ಟು acceleration due to gravity there. Planetally, it is 2 times that. Which of the following could explain this? Now, what is the expression, basic expression for acceleration due to gravity? Small g is capital GM divided by r square, where g is gravitational constant. Now, Gp is the acceleration due to gravity on that planet, which should equal to G. Mp is the mass of the planet and Rp is the radius of the planet. Given what? Acceleration of the planet, acceleration due to gravity on the planet is twice that of the earth. So given Gp is 2 times Ge, acceleration due to gravity on the planet is 2 times acceleration due to gravity of Earth. This can happen only when both mass and radius of the planet are half of the Earth. If you substitute, Mp is Me by 2 and Rp is Re by 2. Only then this condition is satisfied. So the third option holds good. Which of the following substances has the highest elasticity? Rubber, copper, sponge, steel. By superficial analysis, we conclude it has to be rubber. No, my dear students, elasticity depends upon the value of Young's modulus, where stretching and deformation is maximum, and which among the given 4 has higher Young's modulus? It is steel. So steel has the highest elasticity. 9. 3 liquids of equal mass, very important, are taken in 3 cubical vessels A, B and C. Their densities are rho A, rho B and rho C. But very clearly, rho A is less than rho B is less than rho C, then the force exerted by the liquid on the base of the cubical vessel. First, let us analyze what is the force exerted by the liquid on the base of the vessel. Illondu vessel andre it is filled with liquid. So force acting on the base, downward force, which is nothing but the weight. So here, very clearly, the force acting on the base of the vessel due to the liquid is the downward force. So the downward force is the weight, which is m into g. Now g, the factor is a constant, which means the force depends only on the mass of the given liquids. Very clearly they say equal mass. So MA is equal to MB is equal to MC. Mass of all three liquids will be the same. So very clearly FA equals FB, which is equal to FC. All the three liquids exert the same force. Next one. Water is in streamline flow. Turbulent flow alla. Streamline flow along a horizontal pipe with non-uniform cross-section. The cross-sectional area of the pipe is non-uniform. At a point in the pipe where the area of cross-section is 10 meters square, area of cross-section is 10 meters square, the velocity of water is 1 meter per second. Some point inside the pipe, ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಪೈಪ್ ಒಳಗೆ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ 10 meter square idre, velocity of water is 1 meter per second and pressure is 2000 pascals. The pressure at another point where the cross-sectional area is 5 meters square. Now, since it is streamline flow, I will first use my equation of continuity and find the velocity at the second point. So, equation of continuity says A1 V1 is A2 V2. What is A? 10. What is the velocity at that point? Meter per second. A2 is 5 meter per second. V2 has to be calculated. So V2 is nothing but 2 meter per second. Now, using the expression for compressed velocities, non-uniform cross-section, P1 by rho plus V1 square by 2 equals P2 by rho plus V2 square by 2. This is called equation for compressed velocities. Now, what is the pressure here? It is, yes, 2000. Density is nothing but water, 1000. Velocity V1, 1 square by 2. P2 has to be calculated. Again 1000 plus V2 is 2 square by 2. So when we simplify, 500 pascals will be the answer. Next question, students. A very simple one. Temperature of a gas contained in a closed vessel of constant volume. Volume remains constant. Increases by 1 degree Celsius when the pressure is increased by 1%. Keeping volume constant, the temperature of a gas increases by 1 degree Celsius. Pressure is increased by 1%. Then what is the initial temperature of the gas? When the volume remains constant, at constant volume, we have known pressure is directly proportional to temperature. The Gay-Lussac law. Pressure directly proportional to temperature. Now, there is change in pressure by 1%. So, dP by P into 100. There is also increase in temperature, dT by T into 100. dP by P into 100 is to 1%. Pressure is increased by 1%. The temperature increases by 1 degree Celsius. This is the increase in temperature, dT. This is 1 by T into 100. Then what is the value of T? It is 100 degrees Celsius. This question goes for a toss. So the data is abrupt, which went for a grace marks. Two slabs of thickness D1 and D2 are connected in series. Keyword is that the two slabs are connected in series. Here slabs they are connected in series. D1, D2. I say theta is the temperature of the junction. This is theta 1 and this is theta 2. Now K1 and K2 are the coefficients of thermal conductivity. Then the temperature theta of their common junction. What will be the expression for heat flow across the slabs? We know Q is K A theta 1 minus theta 2 into T divided by D. Now understand, very clearly he says connected in series. And because of that, area will be the same, time for heat flow will be the same. And therefore we write Q1 is equal to Q2. So here it will be K1 theta 1 minus theta divided by D1 equals K2 theta 2 minus theta divided by D2. And when you simplify, we get the first option as the answer. This quite number of times I have done in the previous sessions. This is an assignment for you all. Please to take a pen and pencil. Use Newton's law of cooling. 10 degrees Celsius will be the answer. The efficiency of a Carnot's engine is 0.5 when the temperature of the source is T1 and temperature of the sink is T2. He says there is a Carnot's engine whose efficiency is 0.5. So in the first case, eta 1 is 1 minus T2 by T1, which is 0.5, where T1 is the temperature of the source. T2 is the temperature of the sink. The efficiency of another Carnot's engine is also 0.5. Eta 2 is also 0.5 for what values of T1 and T2? Efficiency has to remain same. First engine, efficiency is 0.5. Second engine, 0.5. Then what should be T1 and T2? Understand, efficiency of an engine remains the same when T1 and T2 are changed by the same factor. Same efficiency ಇರಬೇಕಾದ್ರೆ T1 ಮತ್ತೆ T2 ಎರಡನ್ನೂ ಸೇಮ್ ಫ್ಯಾಕ್ಟರ್ ಇಂದಲೇ ಚೇಂಜ್ ಮಾಡಬೇಕು. So if you observe, it is 2 times T1, 2 times T2. The change is the same. So option C is the answer. 2 simple harmonic motions are represented by equations y1 and y2. The ratio of their amplitude. Illi 5, illu 5. So 5 by 5 is 1. No. Equations nodi. Is the amplitude defined by the same phase differences? Same form of equations? No. Equation 1 and equation 2, they are completely of different form. So you cannot equate the amplitudes like that. See, if you assume y1 is 5 sine 2 pi t plus root 3 cos 2 pi t. Now I will reduce this y1 to the form y2. I want this in this form, standard form, for which I multiply and divide by 2 here. So 5 into 2 is 10. Now divide by 2. Sine 2 pi t plus half root 3 cos 2 pi t. On simplification, this is your mental ability. You have to reduce this to the form sin A plus B. I'll give you the final equation. So this turns out to be 10 sin 2 pi t plus pi by 3. Now you assume they are of the same form. Il sin irlilla. I have brought that sign. So y1 is 10 now, or a1 is 10, a2 is 5. So what will be the answer? It is 2:1. Here amplitude a1 is 10. Now here it is a2, 10 divided by 5, 2:1. 17th. A bat flies steady at a speed of 4 meters per second, emitting a sound of 90 into 10 power 3 hertz. So there is a bat which is flying with a velocity of 4 meters per second, emitting a sound wave of frequency 9 into 10 power 3 hertz. So the source of sound is the bat. It is flying horizontally towards a vertical wall. There is a vertical wall. It flies horizontally towards the wall. The frequency of the reflected sound. Now the sound is striking the wall and it is getting reflected. I have to find the frequency of the reflected sound as heard by the bat itself. Andre, here bat is both the source as well as the observer. The bat is generating sound. It strikes the wall. Sound reflects back. What is its frequency as heard again by the bat? So we know F dash is equal to V plus V naught, V minus V naught into F. V is the velocity of sound in air. V minus Vs. Who is the observer? Bat. What is its velocity? 4. 330 minus 4. The bat itself is the source. So F is 90. So this is slightly lesser than 1. So somewhere approximately 91. So the answer has to be 92.1. This I've already done as a previous session work. Depending on beat frequency, 7 beat will be the answer. Conceptual question. Uniform wire of length L, diameter D, density rho are stretched under a tension T. Correct relationship between fundamental frequency, length and diameter. C is the option. Remember, frequency, fundamental frequency is inversely proportional to length and inversely proportional to diameter. Here, simple to understand. Again, this is a long question. Both the charges experience same downward force. The implication is same downward force for which theta is same. If they are experiencing same downward force, theta will be same, and this can happen only if M1 is equal to M2. So only with M1 and M2 the given condition is possible.